There are two more types of angles we need to talk about, and then we will have completed our talk about angles. This next one we sort of talked about. I didn't give it a name, but we discussed the principle of it, so it shouldn't be too hard to go over. And that's the idea of coterminal angles. Let me state how I define coterminal angles, and let me draw your sketch, and then we can work some problems. Hopefully you'll pick it up pretty quickly. Two angles, or it could be, I should say, two or more angles that start and stop in the same place. All right, let me actually draw a little sketch here, and that's not quite clear. Let's just say here, let's talk about radians for now. If we start here, we know up here whoops. It's actually pi over 2 radians. So there's a pi over 2 radian angle. Starts at the x-axis. Turns out the terminal side, which is what we call that, is the y-axis. That's a pi over 2 angle. But sometimes, what if I start here? Well, let me draw another one. What if I start here, and for an angle, I decide to go all the way around? So when I get back to my positive x-axis, how far have I gone in radians? I've actually gone 2 pi. And then I decide to go a little bit further, and I stop right here. Watch this angle. What's the total angle I've gone? I went 2 pi, and then pi over 2 more. That angle is really pi over 2. But now if you compare these two angles, here I started at the x-axis and I stopped at pi over 2. And my angle is pi over 2. Here I started at the x-axis and I stopped at pi over 2, and my angle was 5 pi over 2. But if you compare these two angles, they both started at the x-axis and they both stopped at the positive y-axis. What does that mean? That means that Five pi over 2 and pi over 2 are coterminal angles. Both those angles start and stop at the same place. So the idea of coterminal angles is this idea that you can go round and around the circle and end up basically in the same place. So now we have some problems where we're asked to find some coterminal angles. And actually, you'll see in a minute, the way we do it mathematically is not very difficult. Although here's one point. In the instructions, they ask for one positive and one negative coterminal angle. So what's that mean by positive and negative coterminal angle? Positive and negative means the final angle. If you're looking for a positive coterminal angle, when you give your answer, that angle has to be a positive number. And if you're asked to give a negative coterminal angle, that means that that final answer has to be a negative number. So let's do this. As we do some examples, I think you'll see how this plays out. And occasionally, we have to think about this, although usually it doesn't really matter. Now we can do problems in either degrees or radians. So let's start out. Here's one. (100-degree angle), and I want to find one positive and one negative coterminal angles. Now here's the easiest way to do this. If I'm in degrees, just to show you what I'm going to do, 100 degrees is about right here. Easiest way to get a positive coterminal angle is you just add 360, right? So here's 360, and then you go 100 degrees more. So for the positive angle, you take your original angle and you add 360. So a 100-degree angle and a 460-degree angle start and stop at the same place. And since this angle here is a positive angle, that's the positive coterminal. What do you do for a negative coterminal angle? What you do is in a sense, you subtract 360. So if you're looking for positive coterminal angles, you add 360. If you're looking for a negative coterminal angle, you can subtract 360. And once again, because it's a negative number, that is a negative coterminal angle. So coterminal angles are very simple. If it's in degrees, you simply add or subtract 360 degrees. If it's in radians, well, let's do a radian problem before I actually tell it to you. How about our initial angle is 2 pi over 3. So if in degrees, we added 360 or subtracted 360 to get coterminal angles, what do you think we should do in radians? Well, 360 degrees is the same thing as 2 pi. So for the positive, let's add 2 pi. Of course, now we got a little bit of math to do because we have to add a fraction and a number. So just to make this clear, let's, instead of writing 2 pi, let's call it 4 pi over 2. Whoops! It's 3 here. How about 6 pi over 3, which is 2 pi? So when I'm all done, I can say 8 pi over 3 and 2 pi over 3 are coterminal angles. In this case, a positive coterminal angle. If I want a negative coterminal angle, you take the initial angle and now you subtract 2 pi. Did it again. You subtract 2 pi, which in this case is negative 6 pi over 3. And there's a coterminal angle, but because it's actually a negative angle, we call that a negative coterminal angle. Now, let me see if there's one more kind of problem, and there might not be one here, but I might just make one up, just to help you understand. What would happen, and I don't see one here, but I want you just to understand the principle. Here's what happens occasionally. Let's just make it simple. Let's just say my initial angle was 3 pi, and I was asked to find one positive and one negative coterminal angle. So for the positive, I'm going to simply add 2 pi to 3 pi. That's pretty straightforward. For the negative, I'm going to subtract 2 pi. But look at my answer for the negative coterminal angle. I've said it a couple times. A negative coterminal angle is when you subtract 2 pi or 360 degrees, but your final answer needs to be a negative number. Turns out this angle is still positive pi. It's almost like I've gone around the circle in reverse once, but I still have a positive. So what do? You take this and you subtract 2 pi again. And now my angle is negative pi. All three of these, negative pi, pi, and 3 pi, are coterminal angles, except now I finally have an angle that is negative. So there's my negative coterminal angle. All right, last topic concerning angles. So other times we're given an angle, and sometimes you're asked to find the complementary angle, or sometimes they'll say find the supplementary angle. So what's that about? Basically, if you take an angle and you add to it the complementary angle, in terms of degrees, they equal 90 degrees, or in radians, pi over 2. So it's basically two angles that add up to 90 degrees. And for supplementary, if you take an angle and you add to it its supplementary angle, those two angles have to add up to 180 degrees, or in radians, should add up to pi. So, how does this play itself out with problems? So here's an example. Find the complementary angle of a 65-degree angle. Sometimes you can almost do these in your head, although sometimes you occasionally have to do some math. So let's think about it both ways. In terms of just common sense, if I have a 65-degree angle and I'm asked to find the complementary angle, I need to find the angle that added to 65 would equal 90. Why do I have to add to 65 to get 90? 25 degrees. So 25 degrees would be the complementary angle of this 65-degree angle. If you want to do it mathematically, which you have to sometimes, you can always just take, since a complementary angle is equal 90, if you take 90 degrees minus 65 degrees, and that gives you your complementary angle. Matter of fact, here's one that, well, let's do one in radians. So, the complementary angle of pi over 6. Now, some of you, if you can do it in your head and you're pretty good with fractions, you can do that. Let's go ahead and do it mathematically. So for complementary angles, it's two angles that add up to pi over 2. So therefore, the complementary angle would be pi over 2 minus pi over 6. If the two angles have to equal pi over 2, and we're given one angle as pi over 6, the complementary angle is pi over 2 minus pi over 6, which I need to get the common denominator. 2 pi over 6, which reduces down to pi over 3. So the complementary angle of pi over 6 is pi over 3. And if you add those together, it should equal pi over 2. So finally, we can do a couple of supplementary problems. How about you're given a 30-degree angle. Let's find both the complementary and the supplementary angles. Complementary, pretty straightforward. 90 degrees minus your angle, 90 minus 30. Complementary angles, 60 degrees. Supplementary, 180 degrees minus 30, 150 degrees. Let's do one more radian problem. How about the angle is 3 pi over 4. Whoops. Oh. You notice I could not, this doesn't have a complement because it's already bigger than pi over 2. Let's just do the supplementary angle. So it's going to be pi minus 3 pi over 4. 4 pi over 4 minus 3 pi over 4. Looks like pi over 4 would be the supplementary angle. All right, lots of different kinds of angles. And now we've covered them all. So the next kinds of problems we're going to look at are actually starting to talk about actual trig functions. So let me stop now, and then we'll start talking about trig functions.